This is the properties of parallelograms practice. So this is our first one. So this assignment was given the week of December 3rd. I think on that Wednesday we completed the first 8. And then today, December 10th, we're completing the rest of it. So numbers 9 through 17. So we're going to go through all of it. So again, parallelograms are defined by having 2 pairs of parallel sides. And the other properties that parallelograms have, right? So in addition to having 2 pairs of parallel sides, which define it, it also has opposite sides that are congruent, okay, opposite angles that are congruent, consecutive angles that are supplementary, and the diagonals bisect each other. So those are the 5 properties of a parallelogram. So the first one here, a quadrilateral with 2 pairs of parallel sides is a parallelogram. And that's how we define a parallelogram, as a quadrilateral with 2 pairs of parallel sides. The opposite sides of a parallelogram are going to be congruent. The opposite angles of a parallelogram, we said, are going to be congruent. And the consecutive angles of a parallelogram are going to be supplementary. And the diagonals of a parallelogram bisect each other. Okay, those were our 4 properties. So again, if we have a parallelogram for this one, right, for example, again, it's defined as having 2 pairs of parallel sides. So these sides are going to be parallel. Okay, if we name this A, B, C, and D, AB is parallel to CD, and BC is parallel to AD. Opposite sides of a parallelogram are congruent. Okay. So opposite sides are congruent, meaning the length of the sides, the opposite sides are going to be the same. Opposite angles are congruent. So again, opposite angles. Okay. This is A, B, C, and D. A and C are opposite angles, and B and D are opposite angles. So A and C are going to be congruent, and angle B and angle D are congruent. Okay, consecutive angles are supplementary. So consecutive angles are the ones that are right next to each other. So A and B are consecutive angles. So A and B, the measure of angle A plus the measure of angle B is going to be 180, because consecutive angles are supplementary. Okay. B and C are going to be consecutive, therefore they're going to be supplementary. C and D, and A and D. Okay, and then the last property here, the diagonals bisect each other. Okay, so if we have a point E in the middle, right, these segments and these segments are going to be congruent. Okay, it bisects, it splits of the segment in half. We're going to see some examples of each. So we've talked about these definitions, we've gone over this, and we've shown you how each of these properties works. But let's get some problems. That way we'll better be able to see it if you're still confused. We got a few more on there. Name 2 okay, so we're going from the diagram that we have here. So name 2 pairs of congruent angles. So we either have opposite angles or consecutive angles, and we know opposite angles are congruent. So let's start with angle H. What angle is opposite angle H? That's going to be angle A. It's on the opposite side. So angle H is going to be congruent to angle A, because it's telling us that this is a parallelogram, right? MATH is a parallelogram. Then we also know angle T is going to be congruent to angle M, because they are opposite angles. Opposite angles are congruent. Okay, name four pairs of supplementary angles. So we know angle M and angle A are consecutive angles, and we know consecutive angles in a parallelogram are going to be supplementary. So angle M and angle A. Angle A and angle T. Angle T and angle H. And then angle H and angle M. So again, these lines are parallel because it's a parallelogram. So wherever you have same side interior angles, right? We have angle M and angle H, right? They're consecutive because they're next to each other. Okay, and we know if they're consecutive, they're going to be supplementary. Okay, but the reason why they're supplementary is because that they're same side interior angles. So this is our two sets of parallel lines, or one set of parallel lines, right? Line MA and line HT. Here's our transversal. So we notice these two angles, angle MHT and angle HMA, are same side interior angles. And since the lines are parallel, we know those same side interior angles are going to be supplementary. And that's how we know and can prove that our consecutive angles are supplementary, because we could repeat the process over and over again. Okay, number 8, name two pairs of congruent segments. So we know one of the properties up here, I think it was number 2, says that opposite sides of a parallelogram are going to be congruent. So the opposite sides, MA, the opposite side of MA, what's across from it, is going to be HT. So MA is congruent to HT. Okay. All right, and then we have MH. What's going to be across from MH? AT. Right, so 5 properties. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. The diagonals bisect each other. Right, and then the 5th one is the way we define the parallelogram, which is that two pairs of opposite sides are parallel. So find all the missing angles and sides, okay, of the parallelogram. So we're assuming they're parallelograms. Okay, so we can apply our properties. So if ON is going to be 4, PQ is also going to be 4, because the opposite sides are congruent. If OP is 6, then NQ is going to be 6, because opposite sides are congruent, right? If this is 4, this one's also going to be 4 because opposite sides are congruent. This one's 6. If OP is 6, then NQ is going to be 6 because opposite sides are congruent. Okay. Angle N and angle P are opposite each other. And we know in a parallelogram, opposite angles are congruent. So angle P is going to be 32. Okay. We know angle N and angle O are right next to each other. Okay, they're consecutive angles, and we know if they're consecutive angles, they're supplementary, so they're going to add up to 180. So we can do 180 minus 32, which gives us 148. So we know this is going to be 148. Okay, then we could either say these two are consecutive angles, and if they're consecutive angles, they're going to be supplementary, so we'll add up to 180, which would make this have to be 148. Or we could say they are opposite angles, and we know opposite angles have to be congruent. So if angle O is going to be 148, then angle Q would also have to be 148. Number 10 is a very similar problem. If XY is 10, okay, we know WZ is going to also have to be 10 because opposite sides are congruent. XW is 7. We know that YZ is going to have to be 7. And again, opposite sides are congruent. Opposite sides of a parallelogram are congruent. And we also know that opposite angles of a parallelogram are congruent. So if angle X is 138 degrees, then if the measure of angle x is 138 degrees, then the measure of angle z is also going to be 138 degrees. Okay. And then we know that consecutive angles are supplementary. So we noticed that angle w and angle z are consecutive angles. So the measure of angle z plus the measure of angle w should add up to 180. So we have to do 180 minus 138, which will give us 42. Okay. Then we know opposite angles in a parallelogram are congruent. So if the measure of angle w is 42, then the measure of angle y is also going to be 42 degrees. Number 11. Okay, let's start with sides. So if AD is 13, then we know BC is also going to be 13. If CD is 12, we know AB is also going to be 12. Since they're parallelograms, right, and we know parallelograms are defined as having two pairs of opposite sides that are parallel, we know that BC is parallel to AD, and we know that BA is parallel to CD. So we know that these opposite sides are going to be parallel. Which means we also know, since we have parallel lines, that alternate interior angles are going to be congruent. So right here we have alternate interior angles, right? If these were our two parallel lines, BC and AD, we know we have alternate interior angles. So if this one's 15, this one is also going to be 15. If this one's 24, then this one is also going to be 24. This one's also going to be 24. Okay. So let me erase it so we can see a little better. So we know this is going to be 24, and this is going to be 15 because alternate interior angles. And the alternate interior angle theorem says that if the lines are parallel, then the alternate interior angles are going to be congruent. So 15 and 15, 24 and 24. So what's that make the whole angle? This whole angle then is going to be 15 plus 24, which is going to give us 39. So if we drew this in here, this is going to be 39 degrees. Okay, and this one down here will also be 39 degrees, right? And opposite angles should be congruent, so that makes sense. Okay, in a parallelogram, opposite angles are going to be congruent. We also know in a parallelogram that consecutive angles are supplementary. So if this angle is 39, we need to find an angle that's going to help add these two up to 180. So angle BAD and angle D are consecutive angles, and since it's a parallelogram, those consecutive angles are going to be supplementary. So if we do 180 minus 39, we'll get 141, which is going to be the measure of angle D. Okay. In a parallelogram, we also know the opposite angles are going to be congruent. So angle D and angle B are opposite angles. Okay, they're across from each other of the parallelogram. So if the measure of angle D is 141 degrees, then the measure of angle B is going to be 141 degrees as well, because those are going to be congruent. Their angle measures are going to be equal. Number 12. So this is where we have our diagonals. So if this is 5, this piece is also going to be 5. It's telling us all these pieces are the same, so this one's also going to be 5 and also going to be 5 based on these two hash marks. Right. So in a parallelogram, the diagonals bisect each other. So this piece, if we made this with an E, F, G, H, so I call this point J. Okay. FJ is going to be congruent to JH, and then EJ is congruent to JG. But in this case, they're telling us that all 4 pieces are going to be congruent. Okay, so we're going to finding out that it's a rectangle. We don't know that right now, but we'll end up finding out in the future that that is a rectangle. What else can we figure out? Well, we know alternate interior angles. Right? We just talked about that one on number 11. So we know that FG is parallel to EH. So we know we have alternate interior angles. So if this is 20, this one is also going to be 20. We also know that FE is parallel to GH. So again, here we have opposite interior angles. So this one is going to be 70. If we notice, we have, a number of different ways we can do this, but we notice we have an isosceles triangle. So if this angle is 70, this one is also going to be 70. Right? Isosceles triangle, so this is 70, this one's also 70. Again, we have an isosceles triangle, so that's 20, this one's going to be 20. If that's 20, this one's going to be 20, because here again, isosceles triangle. So we know that these are all going to be 90-degree angles. So it's 20 plus 70 is 90. Doesn't look like we can find the sides, can we? I don't think so. Maybe I'm missing something, but I think we're good. Okay, I think we're good. Diagonals bisect each other. Okay, 13 here. Okay, this one's a good one. This is a better one than the last one for the property of parallelograms, where it says diagonals bisect each other. So here on 13, it's telling us dx is 4. Is this too small? No, I think we're good. Dx is 4 and ax is 6. Okay, it tells us we need to find bx, xc, bd, and ac. So it's telling us it's a parallelogram, right? Parallelogram ABCD. So we know it's a parallelogram, which means we know that it has two pairs of parallel sides. We know opposite sides are going to be congruent. We know opposite angles are going to be congruent. We know consecutive angles are going to be supplementary. And we know the diagonals are going to bisect each other. Okay, so again, the term bisect means we're splitting it into two congruent segments. So let's first name our diagonals. So here's our diagonals. Okay, we have DB and AC. Those are our two diagonals, DB and AC. Okay. And the property says that the diagonals bisect each other. So that means DB splits AC into two congruent pieces. So where do they intersect? They intersect at X. So DB is going to split AC into two congruent pieces. So if AX is 6, XC is also going to be 6, because we know AX is congruent to CX. So we know AX is going to equal CX. So 6 is going to equal 6. So AX and then XC is going to be 6. Okay, so they bisect each other, so they bisect the other way too. So AC also bisects DB. Okay, so AC is bisecting DB. We're splitting DB in half. So here's DB. Okay, it's this segment right here. Okay, where they intersect at X is where we split it in half. So what's half of DB? DX. The other half is going to be XB. So if DX is 4, BX is going to be 4 as well. Now they're asking us for BD. So here's BD. Okay, we can simply do segment addition. So DB is going to equal BX plus XD. So 4 plus 4 gives us 8. So BD is 8. Then likewise, again, we're looking for AC. So it's made up of two parts, 6 and 6. So if we put those two parts together, we'll get AC. So 6 and 6 gives us 12. So the length of AC is 12. Number 14. Okay. Measure of angle ABC is 120. So this whole thing right here is 120 degrees. And then the rest of the stuff we're given is from the diagram. So let's erase this so we can see what we got. All right. First thing I notice, okay, is that we have, we can fill in all the pieces in the middle. Okay. If we look at x is going to form a linear pair. Right, so x is part of x. I think x is just the point. I don't think it's a variable. Yeah, x is just the point. That's just point x in the middle. So we know angle DXC and angle CXB. DXC and CXB form a linear pair. We know these two angles here form a linear pair. So if this one's 50 degrees, right, 180 minus 50 is going to give us 130. We know this one is going to be 130 degrees. Right? If they form a linear pair, they're supplementary. So their angle measures add up to 180. And then we know these two angles are vertical angles. So this one's going to be 50 because those are vertical angles. Okay, we know this one's going to be 130 because those are also vertical angles. The other thing I notice is I have two of the angle measures for a triangle. Okay. And I can find the last one here if I add all three of these angles up to 180. So 40 plus 50 plus the measure of angle 2 is going to equal 180. Right? Let me, can you guys see that fine? 40 plus 50 plus the measure of angle 2 is 180. So 40 plus 50 plus the measure of angle 2 is 180. So that gives us 90 plus the measure of angle 2 is 180. Subtract 90 from both sides. The measure of angle 2 is going to equal 90 degrees. So this is a right angle. It doesn't really look like it, but it is going to be a right angle. Okay. I'm just going to write 90 because that looks a little awkward. Just write 90 in there. So what else do we know? Well, we know it's a parallelogram, so we know the opposite sides are parallel. So we know we have alternate interior angles, right? So if we have AD is parallel to BC, okay, we're going to know alternate interior angles here. Oops, I'm sorry. Alternate interior angles, these are going to be alternate interior angles. Since the lines are parallel, the alternate interior angle theorem says if the lines are parallel, and they are, then the alternate interior angles are going to be congruent. So if they're congruent, their angle measures are the same. So if the measure of angle 2 is 90, the measure of angle 4 is also going to be 90 degrees. All right, and then here, we now have two angles in the triangle. Okay, we can add those up, 280, or we can do alternate interior. Okay, so we know that this one is going to be 40 degrees. Well, let's see what we got here so far. So we got to go back to our given. So that's what I was was a little lost on where I was going. And go back to the problem, go back to the beginning, and we see that the measure of angle ABC. So let me erase some of this. Okay, I was a little concerned there, but no, they give us more information. So we found out that this was 130, this was 50, this was 130, right? Those are vertical, those are vertical. These were a linear pair. We knew linear pairs were supplementary, so they added up to 180. We found the measure of angle 2 because we know 40 plus 50 plus the measure of angle 2 is 180. So we know this was 90 degrees. They're telling us, right, when we found that this was 90 by alternate interior angles. Okay, then they're telling us the measure of angle ABC. So this whole thing right here, they're telling us that is 120 degrees. Okay. So if this whole thing here, these two pieces put together is 120, and that's 90, this one is going to have to be 30. Right, 120 minus 90 is going to give us 30. Right, the measure of angle 3 plus the measure of angle 2 is going to be 120. Right, and we found the measure of angle 2 to be 90, so the measure of angle 3 plus 90 is 120. Then we subtract the 90 from both sides, and the measure of angle 3 ends up being 30 degrees. Okay. So if this one's 30, this one right here is alternate interior. So if that's 30, this one's also 30. Okay. And then we can do our triangle sum theorem here. So 30, 120, and 1. So the measure of angle 1 plus 30. I think I'm on the, move down. You guys can't see it real well if I write it in black. So measure of angle 1 plus 30 plus 120 equals 180, right? 30 plus 130 plus the measure of angle 1 equals 180. So this becomes 150. Measure of angle 1 plus 150 is 180. Subtract 150 from both sides, and we get the measure of angle 1 is going to be 30 degrees. So 30, 30. I'm sorry, this is 130. I'm sorry, this is 130, which makes this 160. Which makes this 20. So the measure of angle 1 is going to be 20 degrees. See, let me explain. So what I did is when I got 30 here, I said 30 and 30 is 60. 60 and 130 is 190. And I recognize that the three angles of a triangle have to add up to 180, not 190. So by double checking my work, I was able to see that I got the answer wrong. Then I could go back and look at my work and see what I did wrong. And I just made a silly mistake. I wrote 120 instead of 130. So I think that shows why it's important to check your work and make sure you have the right answers down. Okay, you can always double check, right? 90 plus 40 plus 50 should be 180, and it is. Okay. Right, now we have 14, 15, and 16. They want us to know if they are congruent or supplementary, and what equation we can set up. So they want us to set up, and they want us to solve, so we can solve those equations. Okay, that's the easy part, though. So 14, okay. We notice we have opposite sides. What do we know about opposite sides? We know in a parallelogram, and these are parallelograms because it's telling us they're parallelograms. All right, so we're given that it's a parallelogram. So we know in a parallelogram, opposite sides are going to be congruent. So opposite sides are congruent, and our equation is 2x plus 8 equals 14. Okay. Minus 8. 2x is going to be 6 divided by 2. X equals 3. Number 16. We have two angles that are right next to each other. Again, we have a parallelogram because it's told us we have a parallelogram. Okay, we have angles right next to each other. So if they're right next to each other, they're consecutive angles. And again, they're same side interior angles. That's how we can determine that they're supplementary, right? But if you have same side interior angles, you know you're going to have consecutive angles. So consecutive angles meaning they're right next to each other. Okay. Right next to each other, they are supplementary. Their measures add up to 180. So 2x plus 20 plus 3x plus 10 equals 180. So combine like terms, that gives us 5x plus 30 minus 30 from both sides. We're going to subtract 30 from both sides. We get 5x is 150. Divide both sides by 5. X is going to be 30. 30? Yeah. I don't know why I double second guess that, right? 5 goes into 50 10 times, and 50 goes into 153 times. So 150 divided by 5 is 30. Number 17, we have angles. So are the angles opposite or consecutive? They are opposite angles, and we know opposite angles are congruent. So their angle measures are the same. So our equation is going to be 8x minus 6 equals 98. We're going to add 6 to both sides. 8x is going to be 104. Divide by 8. X is going to equal, so it goes into 80 10 times, 24 3 times. So it's going to be 13. We can double check. It goes in once, 24 3 times, 13. So I think that's it for this one. So if you're doing that, yeah, they have a blank for your X. So yeah. This is the Parallelograms. One second. I can't multitask here. Oh, there we go. This is the Parallelograms practice with properties practice from December 10th.